Good morning to all of you. Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this lecture, today I am going to discuss about Part C, Definitions and Short Answer Type Questions from Module 2. We want to discuss in detail Part C, Definitions and Short Answer Type Questions from Module 2. So here I define several definitions and several short type short type questions in this lecture. First of all, I want to suggest some references of textbooks which are very useful in engineering mathematics for second semester. So there we have given two references of textbooks. According to my knowledge, these books are better for engineering mathematics, and the authors are, first book, the authors are N.P. Wali and Dr. Manish Goyal. Publications, Lakshmi Publication Private Limited. Other textbook is the name of the authors, H.K. Das and Dr. Rama Verma. Publications, S. Chand and Company Private Limited. So request to all students, please study of these books thoroughly and prepare all contents given in the syllabus. So now in part C, definition and short answers type question from module 2. The question 1 is given here, which is very short question. Write down the solution of the differential equation. Write down the solution of the differential equation. So, very short solution. Here d square plus 3d and plus 2 into y is equal to 0. This is question 1. Now this is the differential equation of second order with constant coefficient and right hand side is 0. In this question, this is the value of q. Q is 0 here. Q is 0. So, pi, particular integral is 0. Q is 0 and pi is 0. So, y is equal to CF plus pi is complete solution. But pi is 0, so only CF. Y is equal to CF. We want to find CF of question 1. So here, finding auxiliary form of 1. Auxiliary form is m square plus 3m plus 2 equal to 0. Putting d equal to m and removing y from 1. After factorizing, we get here m square plus 3m plus 2 equal to 0. This implies that m equal to minus 2 and minus 1. So CF is C1 e to the power m1x plus C2 e to the power m2x. So CF is C1 e to the power minus 2x and plus C2 e to the power minus x. And this is y. CF is y. Y is equal to C1 e to the power minus 2x plus C2 e to the power minus x. This is answer. Here we see that roots of an auxiliary form are different. Okay. So m equal to m1 and m2. So CF formula of CF is C1 e to the power m1x plus C2 e to the power m2x. So CF is C1 e to the power minus 2x plus C2 e to the power minus x. So y is equal to CF equal to C1 e to the power minus 2x and plus C2 e to the power minus x. So this is the solution. This is complete solution of 1. Next, write the solution of the differential equation. Solution: 4d square minus d plus 1 into y is equal to 100. This is equation 1. So here, this is differential equation of second order with constant coefficient. So here we find solution of 1 is y is equal to CF plus PI, because Q is given, Q is 100, so Pi is not 0. Q is 100, in right hand side is Q. So Q is 100 here, so Pi is not 0. First of all, we find CF of 1. CF of 1, complementary function of 1. So putting d equal to m, and first of all, first we find CF of 1, then putting Q is 0. Putting Q 0. So equation 1 is 4d square minus d plus 1 into y is equal to 0. This is equation 2. So now auxiliary form of 2. Auxiliary form of 2 is putting d equal to m and removing y from 2. Auxiliary form of equation 2 is putting d equal to m and removing y from equation 2. Then we get here 4m square minus m plus 1 equal to 0. So m square, so finding roots of this. What is roots of this here? 4 minus 3. So here a equal to 4, b equal to minus 1 and c equal to 1. Apply formula here. Y is equal to m is equal to minus b plus minus under root b square minus 4ac upon 2a. This is formula. So here minus b means plus 1, under root plus minus 1 minus 4 into a into 4 and c into 1 and upon minus 2 into 4. So here 1 plus minus under root, here is minus 15 upon 8. So here 1 by 8 and plus minus I root 15. So here m equal to alpha plus minus I beta. So alpha is 1 by 8 and beta is root 15 by 8. So CF is C1, CF is e to the power alpha x and C1 cos beta x plus C2 sin beta x. So now y is equal to CF. So e to the power alpha is 1 by 8. E to the power x by 8 and in C1 cos root 15 by 8 x and plus C2 equal to e to the power 1 by 8x and in C1 cos root 15 by 8x and plus C2 sin root 15 by 8x. Okay. This is CF. Now PI. PI equal to here. PI equal to 1 upon 4d square minus d and plus 1 into 100. So hundreds are constant, taking out, and minimum 1 is taking. So is PI is here 1 is taking common 100 and 1 plus 4d square minus d upon 1 whole to the power minus 1 and 1 here. So answer is 100. So y is equal to CF plus PI is complete answer. So complete answer is complete solution of 1 y is equal to CF plus PI. Okay. So this is the complete solution. Now problem 3. Here solution of 3 question 3. This is very short question. Here d minus 1. PI, find the particular value of this question. So here find the particular value of 1 upon d minus 1 into x. This is equation 1. Now particular value, particular integral, PI equal to d minus 1 into x. Here minimum power d is taking common. So minus 1 is common. And here is 1 minus d upon 1 whole to the power minus 1. Here is x. This is binomial. This is binomial. Now binomial is 1 minus x to the power 1 minus x to the power minus 1. This equal to 1 plus x square plus x cube. This is infinite series. Okay. So here pi is equal to minus is common 1 plus d square plus d cube and plus this up to infinity and here is x. Now multiply by x here. So but we know d of x is 1. D square of x is 0. And d cube of x is d cube of x is 0. Other all derivatives are 0. So here pi is equal to multiply by x, here minus x, x बन जाए x plus dx. Other all terms d square x dx plus d square x and plus this. So all terms are 0. We write here pi is equal to minus x and dx is plus 1. So minus x plus 1 is pi. This is particular integral of 1 upon d minus 1 into x. Next result, solution. Find the particular of this question. Find solution. Pi of 1 upon d minus 2 and d minus 3 whole to the power e to the power 2x. This is question. So how we can find pi here? Pi equal to 1 upon, multiply this, d square minus 2d minus 3d plus 6 and into e to the power 2x. So now pi is equal to 1 upon d square and minus d square minus 5d and plus 6 e to the power 2x. Now taking minimum power of d is common. Minimum power of d is common. So minimum power is here d square, d to the power 1, here d to the power 0. D to the power here, d to the power here 0. So 6 is taking common. So now pi is equal to 1 upon 6 is common. And in bracket here is 6 is common. So 6 taking common here. So here 1 plus d square minus 5d upon 6 whole to the power minus 1 and e to the power 2x. X square होगा, e to the power 2x not there. Maybe e to the power 2x, okay. Not binomial, we are not making binomial. So sorry, here is wrong. Here e to the power 2x, so we not making binomial, okay. Here क्योंकि function is, here q is e to the power 2x, okay. So putting d equal to putting d equal to 2. What denominator is not 0? What denominator should not be 0? Should not be 0. Putting d equal to 2, but denominator should not be 0. Okay. So here putting here pi is equal to 1 upon d equal to 2, e to the power 2x, d equal to 2, 2 का square minus 5 into 2 and plus 6, e to the power 2x. But we see here that 1 upon 4 minus 10 plus 6. e to the power 2x. So here 1 upon 10 minus 10 e to the power 2x. So this 1 upon 0 e to the power 2x. But here we see that putting d equal to 2, then denominator 0. Denominator 0. Denominator is 0. Then method change. Then method change here. What change? Now pi is equal to this exponential function taking to this side. And here putting d equal to d plus 2. Exponential function taking left side and putting d equal to d plus 2. So here d plus 2 ka square and minus 5 into d plus 2 and plus 6. And here is only 1. Function is 1. So here after opening pi is equal to, we write here e to the power 2x and here 1 upon d square plus 4d plus 4 and minus 5d minus 10 and plus 6. Okay, here is 1. D square plus 4d plus 4 minus 5d minus 10 plus 6 here. Minus 5d plus 10 minus 5d minus 10 and plus 6. This is 1. So now this pi is equal to e to the power 2x and 1 upon here. D square 4d and 5d. So d square minus d and 4, 6, 4, 10. 10 is cancelled. So this is only here. Here is 1. Now d is common. E to the power 2x. And here is minus d is common. And here is 1 minus d square. 1 minus d. D is common. So 1 minus d to the power minus 1. So here is 1 only. 1 function. Now after multiplying this, we get here e to the power 2x minus sign e to the power 2x and integration of 1 dx. So final answer is pi is equal to e to the power 2x minus e to the power 2x into x. This is pi. Because if we expansion by this binomial, then we get 1 plus d square plus d cube. But function is 1, so we get only here 1 function. 1 function and here is denominator d. So denominator d means 1 upon d. 1 upon d means integration with respect to x of function 1. So we write here this result. Okay. Here minus 10 plus 6 plus 4 plus 4 plus 6 10. 10 minus 10 is cancelled. D square plus 4d minus 5d. So here is minus d is d square minus d only. Here is function 1 only. E to the power 2x taking left side. So now d is taking common here in denominator. Minus d because this is must be positive 1. This should be positive 1. So here minus d is common. First term is 1. And d square, this is negative term minus d whole to the power minus 1. We are taking in numerator. After opening this by binomial, then we write this formula here. 1 minus d to the power. So this result 1 plus d square plus d cube. Now multiply by 1 here. Then all derivatives are 0. Only single 1 is remaining there. So e to the power minus 2x integrating with respect to x, then we get this answer. Okay. Next, solving differential equation. This solution: d4 minus 2d cube minus d square plus 4d and plus 4 into y is equal to 0. This equation 1. So this is the differential equation of fourth order and first degree with constant coefficient. But we see here right hand side q is 0. Q is 0, then pi is 0. So y is equal to Cf plus pi. Cf plus pi. But pi is 0, so y is equal to only Cf. This is answer. Okay. Now finding auxiliary form of 1. Putting d equal to m and removing y from 1. Then we get here m4 minus 2m cube minus m square plus 4m m plus 4 equal to 0. This equation 2. Now factorizing this. How we can factorizing this here? Here is factorizing. Now next, m4 minus 2m cube plus minus m square plus 4m plus 4. This equal to 0, equation 2. Now factorizing. This. Factorizing. How we can factorizing this? So there are 4 roots of the equation. So here m is common here. In this bracket m square is common. And we get here m square minus 2m minus 1. This equation is minus d square. Minus d square 4d plus 1. Okay. So here is 1 and here is 1. 4 2 is 8. How we can factorizing this here? Now minus 4 minus 4. This is minus 4. Minus 4. Here is plus. M square is common plus. In this question, here is d square plus d square. Here is plus d square. Okay. There is some mistake in our question. So writing plus d square. So here is plus m square. So here is plus m square. Clear? So here m square is common and putting here m square minus 2m plus 1. And here is m minus 1 ka whole square. Then that is not common. So factorizing this result, how we can factorizing this result? Here is minus sign. Here is also minus sign. Here is minus sign. So now factorizing this result. Here is minus sign. Okay. Now factorizing this result. Any value putting here minus 2 ka 4 and minus 2 into minus 2 ka cube. So here is plus 16 and here is 2 2 is 8 minus 16 and here minus 2 ka square means 4 and here minus 2 means minus 8 plus 4. Here is minus 2, minus 8, and here is minus 2. So here is minus 2. Here is plus. Now this is maybe plus here, 100% plus. So here is plus. Here is also plus. Clear? So putting m equal to here minus 2. Putting here m equal to minus 2 is a factor. So minus 2 ka 4 and minus 2 into minus 2 ka cube, and here is plus minus 2 ka square and plus 4 into minus 2, and here is plus 4. So now this equal to, here is 16, here is plus 16, minus minus plus 16. So in this question is there some mistake. Now I am solving next question. Solving this question here. Question 6. Solution. Solving differential equation this. D to the power 4 minus 1 into y equal to 0. This is 1. So now, first of all, q is here 0. So pi is 0. Y is equal to cf plus pi. But pi is 0 here. So y is equal to only cf. Okay. Y equal to only cf. So now finding auxiliary form. Auxiliary form. Okay. Auxiliary form of 1. Putting d equal to m and removing y. Removing y from 1. Then we get m to the power 4 minus 1 equal to 0. So how we can factorizing this here? There m square minus. So here is m square plus 1 and m square minus 1. This equal to 0. So m square plus 1 equal to 0. Then m square equal to minus 1. M square plus 1 equal to 0. Then m square equal to minus 1. M square equal to I square. So m equal to plus minus I. Okay. This is 1. Next is m square minus 1 equal to 0. So m square equal to 1. So m equal to plus minus 1. Okay. So there are 4 roots. There are 4 roots. 4 roots of 1. First is m equal to 0 plus minus I. So this is alpha plus minus I beta. So alpha is 0 and beta is 1. Next is m equal to m1 is 1 and m equal to m2. m2 is minus 1. So we apply formula for CF. CF equal to C1 e to the power m1x plus C2 e to the power m2x and plus e to the power alpha x C1 cos beta x and plus C2 sin beta x. So CF equal to C1 e to the power x plus C2 e to the power minus x plus C1 cos x and plus C2 sin x. All values, these roots putting in this formula. So we have written the formula is this. This is formula. This is the different roots, minus 1 and plus 1, and this is the imaginary roots. plus minus I. So alpha is 0 and beta is 1. Putting here, then we get this result. So this is the complete CF and this is solution of the question. This is equal to y. This is y equal to. Okay? Y. Next result, write the particular value of these questions. So here is sin AX. This is sin AX, not cos AX. So Pi is equal to, we write only formula, not giving a proofing. Pi is equal to 1 upon d square plus a square n into cos AX. So formula Pi 1 upon f d square into q. This is the formula. So here putting d square equal to minus a square. Putting d square equal to minus a square. So here f minus a square is 0. So we apply direct formula. Here 1 upon d square plus a square n into cos ax. So cos, sin is negative, cos is positive. So here is plus x upon 2a and sin ax. This is the answer. Pi. And qi is this next to sin ax. Pi of 1 upon d square plus a square. Next 1 upon d square plus a square and sin ax. So this is pi. So this equal to, this is sin. Sin means negative. X upon 2a and into cos ax. This is formula. Pi of 1 upon d square plus a square and cos ax. This equal to x upon 2a and sin ax. Cos a, sin convert in cos. If sin is then minus sin. And here cos is then plus sin. So these are two formulae. There is proof of these formulae in particular integral. Now find particular integral of this. There is some wrong question. I am writing correct question here. D square minus 3d and plus 2 into y equal to cos 2x, suppose cos x. This is question. Here is some wrong question. So I am writing correct question. Any question I am giving here. So I am solving here. Particular integral we are find only here. We are finding only particular integral, not CF. So here Pi is equal to solution d square minus 3d and plus 2 into y is equal to cos x. Okay, this is equation 1. Now Pi is equal to, what is Pi? 1 upon fd into q. This is formula. This is 1 upon fd means d square minus 3d and plus 2 into cos x. Q is cos x. Basically this equation write as here fd n into y is equal to q. This is the type of equation. F dy is equal to q. So when we finding pi, then 1 upon f dq, q is cos x here. So how we can find pi? So this equal to 1 upon d square minus 3d and plus 2 into cos x. So in this case putting d square equal to minus 1 because a is 1 here. Cos x comparing with cos ax. So a is 1 here. Okay. Putting d square equal to minus a square. So d square equal to minus 1 square means minus 1. These assumptions we are taking here. In our question, q is cos x. Q is cos x. But general is cos ax. So a is 1 here. After comparison here, a is 1. Apply formula d square equal to minus a square. So d square equal to minus 1 square equal to minus 1. So here I am putting same result 1 upon here minus 1 and minus 3d and plus 2 into cos x. Okay. So here is 1 upon minus 3 plus 1 minus 3d plus 1 and into cos x. Minus taking common. So here 1 upon 3d minus 1. Multiply its conjugate 3d plus 1 and here is 3d plus 1 and it cos x. Finding solution minus 3d plus 1 and into cos x. And here upon factorizing this 9d square minus 1. Again putting d square equal to minus 1. Again putting d square equal to minus 1. So minus 3d, this multiply d cos x and plus cos x. And upon 9 minus 1 and minus 1. So here is minus 10. So here is 1 upon 10. Differentiating this d cos x minus sin x. Minus 3 sin x and plus cos x and upon this answer. Okay. This is pi. Particular integral of this. Pi. Next question. Find particular of this integral. This is same question I have taken here. Now pi is solution. Solution here d square minus 3d plus 2 into equal to cos 3x into y is equal to cos 3x. This is equation 1. Last page I have written y or not? Y. So here pi is equal to 1 upon d square minus 3d and plus 2 into cos 3x. So putting d square equal to minus a square, this equal to minus 3 square equal to minus 9 because d equal to 3. Cos 3x comparing to cos ax. So a is 3 here. So here I am putting 1 upon d square means minus 9, 3 ka square, 3d plus 2 and into cos 3x. Okay. So now pi is equal to 1 upon minus 9 plus 2 means minus 3d minus 7 minus 3d minus 7 and into cos 3x minus taking common. So here is 1 upon 3d plus 7 multiply its conjugate. So 3d plus minus 7 upon 3d minus 7 upon 3d minus 7 and into cos 3x. Taking its conjugate of this bracket. Here is taking minus sign minus 1 upon 3d plus 7 into cos 3x. Now multiply its conjugate here minus 3d minus 7 upon 3d plus 7 and into 3d minus 7 and into cos x. So now here pi is equal to here minus 3d cos 3x and minus 7 cos 3x. Multiply this cos x in this bracket, this multiply this and upon. Again putting here 9d square minus 49. Putting d square equal to minus 3. D square equal to minus 9. So we write here pi is equal to minus 3. Differentiation of cos 3x minus 3 sin 3x. So minus 9 sin 3x and plus here plus 7 cos 3x and upon is 9 minus 9 and minus 49. So pi is equal to here minus minus plus 9 sin 3x and plus 7 cos 3x, and upon here minus 81 minus 49. So final answer is pi is equal to 9 sin 3x and plus 7 cos 3x cos 3x upon 910 130, and this is minus sign. Okay, multiply this minus plus, then this minus. Okay, so this is minus sign. This is correct pi of this question. Next question is, now at last question is solving differential equation this. So here solution dq plus 1 y equal to 0. This is question 1. This is the differential equation of third order and 1 degree with constant coefficient. This is known as a differential equation of higher order with constant coefficient. But here in 1, q is 0. This is the type of equation here. F dy is equal to q. Type of equation here. Here writing type of equation. Here function of d n into y is equal to q. This is type of equation. What comparing here? Comparing here in 1 and 2, then we get q is 0. Okay. Then y is equal to, solution is CF plus PI. What q is 0? Q is 0, then PI is 0. Okay. No particular integral. Y is equal to only CF. Now finding CF of 1. Now finding CF of 1. Finding auxiliary equation. Of 1. Auxiliary equation of 1. Putting d equal to m and removing y. Okay. D equal to m and removing y. So we get m cube plus 1 equal to 0. This is equation 3. Factorizing of 3. Factorizing of equation 3. Then we get here m cube plus 1 equal to 0. So here writing m plus 1, next bracket m square and plus 1 and minus m. This equal to 0. Apply here formula a cube plus b cube. So a plus b and a square plus b square minus ab. This identity apply here. So here now first of all m plus 1 0, then m is minus 1. Next m square plus 1, m square minus m plus 1, this 0. So apply formula a is 1, b is minus 1 and c is 1. So here formula is m equal to minus b plus 1 plus minus under root b square 1 minus 4 into a into 1 ac upon 2. So formula of this is here m equal to 1 by 2 plus minus here under root minus 3 by 2. So here 1 by 2 plus minus I root 3 by 2. So this is alpha plus minus I beta. So alpha is 1 by 2 and beta is root 3 by 2. This is the roots alpha and beta. Now formula first is 1. CF. CF is y. First is C1 e to the power m1x plus e to the power alpha x e to the power alpha x C1 cos beta x and plus C2 sin beta x. So now this equal to y is CF only, C1 e to the power minus 1 minus x and plus e to the power alpha xy2 and here bracket plus e to the power alpha xy2 in bracket C1 cos root 3 by 2x and plus C2 sin root 3 by 2x. We can write here y is equal to CF C1 e to the power xy2 minus xy2 and plus e to the power alpha x. Alpha x means 1 by 2 xy2 and in bracket C1 cos root 3 y 2x and plus C2 sin C2 and C3 sin root 3 by 2x. This is complete CF of our question. Complete CF. This is for roots m equal to minus 1. This is for roots alpha plus minus I beta. Alpha is half and beta is root 3 by 2. Imaginary roots. This is the imaginary roots. Okay. First roots is m equal to minus 1. Here m plus 1. So m plus 1 0, then m is minus 1. This is first root. Next root is m equal to alpha plus minus I beta. These roots are imaginary roots. And value of this is this. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.